Well, let's continue with some facts about triangles, specifically inequalities. Let's first define what the median of a triangle is. It is a segment joining a vertex to the midpoint of its opposite side. So, how many medians can a triangle have? Well, there are 3 vertices. Each vertex has an opposite side, so there are 3 medians in every triangle. Now here's a fact, a corollary, called the median inequality corollary. If AM, that's a line segment, is the median from the point A to its opposite side BC in this triangle ABC, then AM, which is the length of the median, from the point A, the vertex, to the point M, is less than 1/2 of AB plus AC. And here we have it pictured. M is the median of BC. It's the midpoint of the line segment BC. And BC as the segment is the opposite side of angle A in this triangle. So here's a nice setup. All it's saying is that this length of AM is less than, what is that? That's the average of the other 2 sides, AB and AC. So this segment is less than half of this plus this. Okay, we're going to do what we call a construction proof. We're going to have to do a little bit of drawing on top of this. Here's the start. All right. So I'm going to write this down here. We need to prove that AM is less than 1/2 of AB plus AC. So I'm going to have to slide up a little bit here. All right, so let's construct a line segment AE. Notice the point E doesn't exist yet, so that M is its midpoint. Well, there's only one way we can do that. Here is AM. We're going to have to extend in this direction because M is going to be the midpoint. So let's extend this out to about there. So if M is the midpoint, we know that length and that length are equal. All right, get back in focus. Okay. All right, so that is supposed to be the point what? E. Okay. Label segment AM and ME as having length X. Okay, so AM has length X. I guess I should have just labeled them with these distances rather than the notch there, but that's fine. Okay, so we've got X, we've got X. Draw CE, okay, connect those 2 points, and label its length as Y. We're now going to prove that X is less than 1/2 of AB plus AC. All right. Notice now that the triangle AMB is congruent to triangle EMC. Okay, why is that true? Well, I'm going to put a couple more marks on this. What does it mean for M to be the midpoint of BC? Well, it means that this length and this length are equal. We also know that vertical angles, this and this are vertical angles. Those are congruent. Okay, so why do we know that triangle AMB is congruent to triangle EMC? Well, notice they both have common side length X they both have a common angle, and then they both have this common side as well. So by side, angle, side, we know that those two triangles are congruent. Then EC, this distance right here, is congruent to BA. Why is that? Because they correspond. They're two corresponding sides in the two triangles. So how do we write that? They're equal by corresponding parts of corresponding figures are congruent. All right. Next, AE, this long distance, AE is less than AC plus CE. Well, that's just the standard triangle inequality. Okay, so that's going to be by the triangle inequality. And I just did this by substitution. AC plus CE, AC plus CE is equal to AB plus AC, because we know that CE and AB, CE and AB are equal, are congruent. They have the same length. So that was by substitution there. Oh yeah, substitution. Okay, so by doing just some simple algebra, we have that 1/2 of AE, just taking 1/2 of the left side, is less than 1/2 of AB plus AC. We took 1/2 of both sides. And remember, AE is less than this, which is equal to this. So that just follows from this statement, we get this statement. Then, since AM, remember what AM is? It's half of AE, because M is the midpoint of AE. So AM is 1/2 of AE. We have that AM is less than 1/2 of AB plus AC. This is just by substitution. This is just M right here. So I replace 1/2 AE with AM, and we get exactly what we needed to prove. Okay, next thing in this video, the last thing I should say, is a theorem called the SAS inequality, or it's called the hinge theorem. So if two triangles, ABC and DEF, are such that AB, I'm going to make triangles out of both of these, but let's go ahead and do this. AB is equal to DE, and I made them so that they are, that's side length is that length. And AC, that side, is equal to DF, so we'll label that F. Those are equal. Then the measure of angle A is greater than the measure of angle D if and only if what? Well, notice the way I drew it, it is slightly bigger. Measure of angle A is slightly bigger than the measure of angle D. And that's if and only if the opposite line segments are in the same inequality. And what I mean by that is angle A bigger than angle D means its opposite side. We've seen something like this already. BC, that's the distance from B to C, that's also greater than EF. Okay, again, we can call that the hinge theorem if we like.